Alright, this is Mr. McMurray for question number 7 on the graphic vector worksheet, and we're going to do this one fairly quick because there are mosquitoes out here and they are getting after me. Alright, so here we go. This one's a little different. You have two forces. They are both 62.0 newtons. Notice capital N here is newtons. That's what we measure forces in, and not north, okay? It'll say north if it means north, okay? Like on number 6, it'll say N north, okay? I'll write the word out for the direction. I will just use N for newtons. Okay. Same thing though. We can use vectors. Okay, to figure out what the resultant force would be. Okay. And so we have two. Now, notice first of all that they go in. The first time there's zero difference in their angle. In other words, they're going in the same direction. Okay. So let's just pick a direction. Let's just say east. Okay. And we're going to say that they're going to go east. All right, let me get my, whoa, do that. Okay, let me move my stuff out of the way here. Okay, so if we have this, we're going to have to, first of all, move it like this so I can measure with it. Oh, I hate that one. It won't go. It's just 180. Like I need it to, but oh well. Okay. Okay, it's gonna have to be a little crooked. Okay, so we'll take that. All right. All right. Let me put your ruler up here. Okay, so the first thing we're gonna do is move it 100 and. Alright, that's just going to bug me too much. We're going to turn it all the way over here if we have to. We'll get it even, okay? So, there we go. Okay, so it's even. And we need to draw a line that is 6.2 centimeters. Okay, so we're just going to go to the east here. Alright, so it's going to go 6.2 centimeters. And it's going to go to the east like so. Okay, and that stops. Now, the second force is going the same direction. So if two people kick it, it's going to have twice the force going that way. So we're just going to, from the end of that line, I'm going to put a little dot right there just to mark the end. Okay, I'm going to go from the end of that line 6.2 more. Okay, because they're going in the same direction, so that's going to make the line go that much farther. Okay, so it's going to go 6.2 more centimeters. Okay, now if I want to find the displacement, then I just measure from where I started right here all the way to the very end here, and surprise surprise, it's going to be equal to twice that, which would be 12.4. Now I moved the decimal. This was 62, I moved it to 6.2, so I'm going to have to change it back to 124, but that's going to be my unit. So right here it's going to have 124 newtons force. Okay, 204 newtons of force. All right, so that makes sense. All right, now the next time the second force is going to be off by 30 degrees. So let me move this out. So the first force is moving. All right, let me move this a little bit. There we go. Okay, that's right. So you want your hole in the middle to be at the end of the first one. Now, instead of going exactly the same direction, it's going to be off by 30 degrees. Okay, so it's going to go up here. Closer there. Okay, 30. Oops. Didn't quite 30. So he's in 31. Okay, 30. Okay, now the next one is going to be off by 60 degrees, so it's going to end up over here. So I'm going to put a dot there. So let me make these dots a little bit bigger so you can see them. Alright, so this is 30. Keep doing that one off. I don't know why. That one's off. Okay. And then there's going to be one at 90, it said. So we're going to do 90. Right at 90 up here. Let me move this out of the way first. Okay. It's going to be right up here at 90. Alright. And the last one's going to be at 180, which would be right over here, wouldn't it? Okay, so I'm going to put it out here where we can see it, but it's 180. Alright, so if we do our vectors like we did before, we can stack them on top of each other. So if this is my first vector, okay, now I'm going to draw this line to go to 30. So let me move this one down to there. Let me move this. Sorry. We're just playing with it. Here we go. Okay, and now let's try this one and move this end up to 30 up there. And now let's try moving this one down again. Close. Okay. Now, if we move this down, we're going to move that to where this is right on 0. And look at that. Mine just happens to be 6.2 out there almost. Okay. So, I have to move it just a little bit up. Put it on 6.2. I need to draw a line 6.2 because we said all these forces are 6.2. This time, it's going to go from here out to there at a 30-degree angle. Okay. Now we know the angle. It's already told us that, so we don't have to worry about the angle on this one. We just need to know what would be the resultant force. Well, the resultant force would be from where we started, okay, which is right there, to where we ended up. So we went here and then went here. The resultant force is going to be that distance from there to there it goes again. And we'll do this one up. Alright, and maybe I can move the whole thing down a little bit. There we go. Okay, so I'm going to measure the distance from there to there. Now, instead of being 12.4 like it was last time, now it's going to be about 12. Actually, my line, well, I'm a little off down here, but it's going to be about 11.9. Okay, so if I did that down here, then I would have to write my answer for this one. It's 30. Sorry, 30 over here. For 30, my answer is going to be, I moved my decimal place, so it's going to be 119.0 degrees, I mean not degrees, sorry, newtons. Okay, it's a little bit less. Okay, then I would draw another line from the middle here out to 60 degrees. I would measure the distance from where I started to where the 60 degree would be. And over here, 60 to 90 will be from there to there when I draw my 90 degree line here. Alright, now the last one, notice if you go 6.2 this way and then you go 180 degrees, which is back this way, 6.2, guess where you're going to end up? Right where you started. So your answer for that one, down here at the bottom, is going to be 0 newtons, okay? Which makes sense. If we had a ball, let me get a little answer here, and we have it right here, and one person hits it with 6.2 newtons this way, and the other person hits it with 6.2 newtons this way, now they should be about the same length because they're the same magnitude, then what's going to happen to the ball? Well, it's not going to go anywhere. It's just going to stay balanced right there in the middle, which is what our results said. It has 0 newtons of force acting on it. Now, these people's feet are going to hurt, but the ball's not going anywhere. All right. Notice that when they're pushing more the same direction, they has more force on the ball. As it gets more to two different angles, then you get less and less force actually acting on the ball. All right. So I'll let you do 60 and 90 and for the rest of that one. All right. Enjoy. Hope you have a good time. And don't forget to submit it when you finish.